Number 33, a fisherman illegally introduces some fish into a lake and they quickly propagate. Propagate just means they make babies. The growth of the population of this new species within a period of a few years is modeled by P of x is equal to 5 times 1.27 to the x, where x is the time in weeks following the introduction of the fish. If a graph of the function is made, decide whether each quantity given would be represented by the growth factor, the y-intercept, the x-intercept, or none of these. So I've drawn a little sketch here. I'm going to rewrite P of x equals 5 times 1.27 to the x. I used the graphing calculator. I punched that equation in here and I drew a graph. I had the graph made here, and really so I sketched it here for you. This part of the graph isn't really relevant because this is before the fish were introduced. So really the part of the graph we're interested in is after the fish come. I'll just put this in like a dotted curve here. So remember, the growth factor is what you're multiplying by each time. Here's the y-intercept. You'll notice there is no x-intercept. So the number of fish the fisherman put into the lake, how many was that? Well, that's the initial amount. That's the 5, and that is the y-intercept. So the number of fish the fisherman put into the lake is the y, represented by the y-intercept. The number of fish in the lake after 5 weeks, that would be somewhere here. That's not represented by any of these. The number of weeks it would take to reach 100 fish. Also, that would be like 100 on this axis. That's not any of these things. And then the growth rate of the fish population each week. Yeah, this 1.27 here is the growth rate. It's the growth factor, so that's represented by this this relationship between going over 1 and multiplying by 1.27.